This time we are going to look at the three size case or the SSS or the three size are provided. Draw the diagram for this problem. We're going to solve the triangle ABC where the side A is 34 kilometers, B is 20 kilometers, and the side C is 18 kilometers. We're going to do as this. A as the longest one, A is 34, and the B is 20, and the C is 18. And the opposite angle here, C, opposite angle, the B, and this is the A. The missing information would be the angle A, B, and C. So we're gonna find angle A, angle B, and angle C. So we're gonna start with finding an angle A. So to find A using the law of cosine in the form that this is gonna find A. So we're gonna use the cosine A equals the b squared plus c squared minus a squared divided by 2 times bc, or the quantity A, which is 20 squared plus the c squared, or the 18 squared minus the A, which is 34 squared, all divided by 2 times 20 times 18. And we get the number as negative 0.6. For the cosine is negative, it has to be in the second quadrant because the restriction for the angle, it has to be less than 180 degrees. And then we're gonna do the inverse cosine of negative 0.6 to get the number out. And using the calculator, it will give us 126.87 degrees as the solution for an angle A. And after that, we use the known information to find the rest of the missing parts. I'll put the partition here. So next, we're gonna find the angle B. This time, we're gonna use the law of sine by using the sine B divided by sine B equals the sine A over the sine A, or the sine B equals B times sine A over sine A, which is 20 multiplied by sine of 126.87 degrees, all divided by the sine A, which is 34. Put in the calculator, you should get the number 0.47058 and so forth. And the sine value is positive. If it is positive, so I put a note here, this is a positive side. The angle B should be in either quadrant 1 or quadrant 2. Compute an angle B using the inverse sine. So B equals inverse sine of 0.47058. And the calculator should give you the number. So I put a note here. So B equals 28.07 degrees. So this one is in the first quadrant. So to obtain the second quadrant, we're gonna subtract this number out from 180 degrees. That should give us 150, 51 point, 151.93 degrees. Okay, so this one is in quadrant 2. And now we're gonna see the possible angle for an angle C. If we use the first solution of an angle B, so C is gonna be 180 minus 126.87 minus 28.07, and it turns out to be the value 25.06 degrees. So that's the first solution, where B is in the first quadrant. And if we use the B from the second quadrant, So the C gonna be 180 degrees minus 126.87 degrees minus 151.93 degrees. We can see that the sum of the last two numbers here is beyond 180 degrees. So then this case is not applicable. So this one is tossed away. This one is tossed away. So therefore we have only one set of the solutions as an angle A equals 126.87 degrees and angle B is 28.07 degrees and an angle C is 25.06 degrees as a solution for this problem. Another case of the problem involving the law of cosine. The three sides are provided. So A as 832 feet, B is 623 feet, and C is 345 feet. Angle C here, angle A right there, and an angle B. We are finding the missing parts would be the angle A, B, and C. We're gonna find A, B, and C. To find an angle A, use the law of cosine. So cosine A equals B squared plus C squared minus A squared, all divided by 2 times B times C, which means we have the square of 623 plus the square of 345 minus the square of 832, all divided by 2 times 623 times 345. And the cosine A comes out to be negative 0.430525 and so forth. The cosine A is negative. That indicates this is in quadrant 1. No, this is in quadrant 2, sorry. For the answer in the quadrant 2, we're gonna keep going by finding an angle A using the inverse cosine, negative 0.4305. And the calculator should give you as 115.5 degrees as an angle A in the second quadrant. We have one solution down. And next, we're gonna find an angle B using the law of sine. The sine angle B equals sine B equals sine of an angle A over sine A, or the sine B equals B times sine A, all divided by sine A. So put the number all together. The sine B equals 623 multiplied by sine of 115.5 degrees, all divided by 832. And we get the number as 0.675854 and so forth. The sine value is positive. If it is positive, an angle B will be in the first quadrant or the second quadrant. Since an angle A is already in the second quadrant or is greater than 90 degrees, so it forced an angle B to be just in the first quadrant. So with this way, we just go ahead using an angle B by looking for the inverse sine of 0.675854, and the number should come out as 42.52. And we got an angle B. And next, we're gonna finish up by finding an angle C using the relationship that all three angles combined equals 180 degrees. So then an angle C is 180 degrees minus 115 degrees, 115.5 degrees, sorry. Minus 42.52 degrees. And it turns out to be C equals 21.98 degrees. So we got the set of solutions. So I'm gonna write as a summary as for the solution, we have an angle A equals 115.5 degrees, angle B 42.52 degrees, and angle C is 21.98 degrees as a solution for this problem.